EDU-ARCTIC 2, Polar Research for Education, innovative program in Poland and Norway. Webinars.
Let me introduce myself. I'm Daniel Kępski and I work at Institute of Geophysics, Polish Academy of Sciences. And today I will tell you about the snow, and especially snow in the Arctic. We will focus on the influence of the snow cover on the Arctic ecosystem. And maybe we will start at the beginning. So about formation of snowflakes, because there won't be any snow cover without snowfalls. So we need there is only two things that are absolutely necessary to have a precipitation in form of snowflakes, and this is the reaching the dew point temperature and the presence of a condensation nuclei. And I know that may sound quite difficult, but I will explain everything in a minute. And there is maybe one more condition that is necessary to have a snowfall: the air temperature below 0 degrees of Celsius. Yes, so obviously we can have a condensation and precipitation above such temperature, but then there will be a rainfall, and we are interested in snowfall. So what about this dew point temperature and so on? So we probably know that in the air there is always something, some water vapor, yeah, so water in the form of gas, and it's in our breath, it's evaporating from the lakes, from rivers, and so on. So there is always some water vapor in the atmosphere, and we probably know that if the air is traveling up, then it cools, then it getting colder. And if it's cold enough, then this water vapor cannot be, because there is some certain amount of water vapor that can be stored in the air, and it strictly depends from the temperature. So if it's colder, this amount of water is smaller. So if the air is going up, then on some level it reaches the dew point temperature and it forms clouds. And if there is this process is going farther and farther, we have the droplets are growing, or snowflakes, and if they are heavy enough, they fall from the cloud in the form of precipitation. And the condensation nuclei is just some solid material that attracts the water vapor. So it can be anything. It can be dust, it can be pollen, it can be soot from the chimney, it can be everything. But it's necessary to have something that can attract the water molecules, because if we have dew point temperature but there is nothing inside the air, if there is completely empty space, the water cannot be condensated, because there is nothing that can attract the water molecule. And as a maybe fun fact, not many people know that all the precipitation on the world, maybe not all, but majority of the precipitation in the world forms as a snowfalls. Because right now I'm in Poland, and the weather is really sunny and it's 25 degrees outside, but clouds form let's say 2-3 kilometers above our heads, and at such level the temperatures can be negative. Yes, so 3 kilometers above our heads it will be negative temperature, so the condensation will be in form of snowflakes, not on a rainfall. And there is also some physical phenomena that allows to having cloud at the same time the droplets in the form of super cold water and the snowflakes. And there is something called Bergeron process, and it generally it's something that attracts the sharp edges of snowflake attract the water molecules more than the spherical cloud droplets. So that's why the snowflake is growing, and the droplets lose the water molecules that join to the snowflakes. And in fact, majority of precipitation in the world, even in the tropics, starts as snowflakes, and then when they fall from the cloud, they travel through the warmer air, and then they melt and form the rainfalls. But on the beginning, at the top, it's probably maybe not all, but very often it starts as a snowflake. Okay, so right now we know something about the snowflake formation, but you probably know that the snowflakes are different. Yes, so if you have an opportunity to look at the precipitation of for example, on your black jacket or something like that, you can see that the snowflakes have different shapes, and it's almost impossible to repeat the snowflake shape. So there is a classification that says that there is 121 types of snowflakes, and you have some examples here on that photo. But obviously, it's just some general shapes. So let's say plate, stellar, dendrite, and so on. But in fact, it's really hard to repeat the same conditions, and almost every plate are completely different. Yes, so the twins happens, but it's really hard to get them. And it's also worth to know that the most important thing that decide about the snowflake shape is the temperature and the let's say air humidity. Here it's called supersaturation. It's maybe a little bit more complicated, but let's say that the most important is temperature and the air humidity. And as you can see, this decides about the form of the snowflake. And it's good to know that the biggest snowflakes are formed when the temperature in the clouds is around -12 degrees of Celsius. So if you, for example, have a temperature like 0 degrees, but you see this beautiful, huge dendrite type snowflakes, you can be almost sure that above your heads, the temperature in the clouds is like -10, -15 or something like that, because it's such temperature forms this kind of snowflakes. And in terms, we are mostly interesting. For us, the most interesting thing right now is snow cover. So the snow on the ground, and it's good to know that snow. To have a snow cover, there should be some conditions. Let's say that snow cover is counted only when the thickness of snow on the ground exceeds a half centimeter and covers at least half of the terrain. So here on the left, we have snow cover, and here on the right, there is some snowfall. There was some snowfall, and we see some snow on the ground, but it's not a snow cover yet. It's not covering all the ground. It's not deeper than half centimeter, so it's not a proper snow cover. We are interested mostly about something that we see on that picture. And yeah, few words about snow metamorphism. So I also want you to know one thing from that lesson, that snow cover change all the time. It's not like we have the snowfall and the snow crystals will be the same during whole the winter. Yes, so they are changing inside the snow cover. And here we have some picture that looks complicated, and that is complicated, yeah. But this is only shows to show you that almost everything influences the snowpack. So there is solar radiation, there is some long wave radiation from the clouds, there is wind activity that forms snow drifts, there is some heat exchange between the ground and the snowpack, and so there is a lot of factors. And yeah, this is something that change our snowpack. But the most important thing is the temperature again. So temperature decides about the type of metamorphism that that is going on inside the snow cover, and we can. There are two main types. So isothermal snow metamorphism and temperature graded snow metamorphism. So isothermal metamorphism is when we have the same temperature inside the snowpack. So if we have, let's say, 1 meter of snow, and the temperature will be around 0 degrees at the top of the snowpack and at the bottom of the snowpack, and inside also we have no gradient. Yeah, our snowpack is isothermal, and in such conditions, the snowflakes that were on the beginning inside in our snow cover, they will after a few days will look like that. Yeah. So here we have the more ideal example. So they are rounding, but in fact, in nature, it more often it looks like that. They are rounding, but not for a perfect circle, but rather for some form like here. And completely different thing is when we have strong temperature gradient. So, for example, during the heavy frosts, if we have temperature like minus 40 degrees, then we will have at the top of the snowpack the temperature around minus 40, but at the bottom of the snowpack it will be around 0 because snow cover is really good insulating properties. So at the bottom of the snowpack it will be pretty warm, around 0 degrees, maybe -5 or something, but it's much warmer than the air temperature. That should be like that. So in such snowpack there is a huge temperature gradient, and this temperature gradient make these rounded grains faceted, so more like cubic shape or pyramid shape. And it's really important because this pyramid shape grains are really unstable. So for example, snow cover that are built from such grains is really unstable and can cause avalanches and so on. It's really a danger. And on the opposite side, this rounded grain snowpack is pretty dense, it's pretty stable and doesn't have it in mountains. That such snow cover is let's say safe. And right now we know something about processes that are going on the snowpack. So you can imagine that in different climates the snow cover will look like different, and that's true. So for example, here we have this diagram shows the differences between snow cover in different climate conditions. And you might think that in the high Arctic there is a lot of snow, and yet there is a lot of snow. But in fact, the tundra is in the tundra we don't have a very deep snow cover. It's usually like 50 centimeters. So, for example, in the Europe in mountains, the snow cover could be like 2 meters, meter and a half, or something like that. So in the high Arctic, we don't have really deep snowpacks because there in the very cold conditions there is not a lot of precipitation. That's the general rule. If there is colder, there is less snowfall. That's one reason. And the second reason is that in the tundra we have a strong wind activity that compress this snow cover. It's really dense, and it's really easy to walk on such snow. And for example, in taiga, which is also Arctic, but maybe this warmer part of Arctic, when we have trees. So in such conditions, we don't have wind inside the forest. So this snow is really loose. There is more snow and it's more loose. So it's really easy to it's really hard to move in such snow cover. It collapses under our shoes, boots, or so on. And obviously there will be different in the Arctic and different in the warm climate, because here in Texas there it could be snowfalls, but it will disappear after a few days. And in the Arctic it can be there in 10 months or something like that. And obviously if the snowpack lives 10 months, it's more complicated, have some layers and so on. And this in warm climate it's not like that. So right now we know some about differences, but you may ask why it's important, why we should care about snow cover, why the scientists should put our attention to the snow cover. So in our climate, in temperate, let's say, climate zone, the most important is probably the avalanche danger. So if we know about the snow cover structure, we predict the avalanche danger. So it's really important for the safety of the people. And also very important is the hydrology. So there are countries that depend mostly on the water that comes from the melting glaciers, melting snow cover in the mountains. So if we know how much water is stored in our snow cover, we may predict droughts, or we may predict floods. So, and we can prepare earlier. Yeah? So this is very important. And in the Arctic, it's also maybe the most important, and is the impact on the climate and influence on vegetation. So we probably know that snow is cold, and if we have such the same weather conditions, the ground with the snow will reflect more solar radiation than the bare ground. Yeah, so that's when in sunny day we have white shirt, it will it will cool our body down. Yeah, so it will be reflecting a lot of solar radiation. And if we have black shirt, it will let's say it will be much warmer than we will have the white shirt. So the same situation is with snow cover. Snow cover reflects the solar radiation, makes the ground colder. Yeah. And there is also influence on vegetation is very important. So you may think that snow cover is a bad thing for the plants, but it's completely opposite, at least in the Arctic. So in places where we have deeper snow cover, the plants are bigger and they are in better health. So that's what I said about these insulating properties. So below the snow cover, the temperature is warmer than when there won't be any snow cover. So it's better for plants to have temperature like 0 degrees or -2 degrees of Celsius below the snow cover, then doesn't have any snow cover and be and have temperatures like the air temperatures. So in the Arctic it could be -30, -40, -550 even. So it's much worse for the plants. So snow cover is good. It's good for plants. Obviously, not every snow cover is good for plants, because if there is too much snow, if it's really heavy, it can, for example, broke the trees. Yeah, in the taiga. So it's not always a good thing, but usually it's a good thing. And also there is important influence of in sport and tourism. Yes, snow cover is very important for the sport. So, for example, scientists are right now hired for the Olympic Games or something to to model the snow cover in the condition in some specific conditions to choose the best skis for the conditions to win the competitions or something like that. So there is a lot of things that make the snow science important. And we know that right now that snow cover measurements are important. So what we can measure in snow cover? So the most basic thing is depth, and depth is really easy to measure. You can measure the snow depth using the simple ruler or something like that. If the snow cover is deeper, you can use the avalanche probe that have let's say 3 meters. Their length is like 3 meters or something like that. And obviously we can measure the snow thickness with some automatic devices like this device on the photo that use acoustic sensor. And yeah, if using the simple equation, so travel of the signal and sound propagation velocity, we can calculate how much snow is below this sensor. And when we have a depth, we also can pretty easily measure the density. So it's just weighting the snow. So we need to have some weighting scale, and weigh the snow. And if we have if we know the volume of the snow, that for example we put the snow tube in the tube like here inside the snow, then we will weight this snow with some scale. Here is the scale. Then we will have the density of the snow. And if we have the depth and density of the snow, we can easily calculate the snow water equivalent. So the thing that is really interesting for hydrologists, that to predict the flood event, for example. But if we were more interested in some more detailed information, we need to dig a snow pit. And what is a snow pit? Snow pit is just a hole in the snow. It looks like that, like here. And as you can see, sometimes you can have a really deep snow cover, and this is very time consuming to dig such a snow pit. Yeah? So, and I really want you to know another thing from that lesson, that snow cover is heterogeneous and built from many layers. So it's not a one layer or something like that, but we have some levels in the snow cover. It's more like layer cake, yeah, something like that. So you may do some experiments. If you have some snow cover that, let's say, exists for 2 weeks or something like that, you may pour some colored water on the hole on the snow pit. Yeah, let's say we may dig some snow pit, and we may pour the colored water here, and you will easily see that the water is traveling differently through different layers. So on some layers it will pour really quickly, and there will be layers that will stop the water, and they will form these horizontal layers. So that's maybe the easiest thing to see the stratigraphy of the snow cover. And in such snow pits, we may measure a lot of things, and we don't have time here to to explain every one property of snow cover that we may measure. So I really encourage you to check the educational toolkit and the presentation that is there. And there is explained with some photos what we can measure inside the snowpack. But this is maybe important. So this is a thermal camera image from the snow pit wall, and as you can see, during the cold day we have -3 degrees here at the bottom of the snowpack, and -14 somewhere in the in the upper part near the air. So as you can see, the bottom of the snowpack is much warmer than the top during the chilly frost days. So it's much better for plants to have temperature like -3 than -14. Yeah, that's important. And I told you about these metamorphisms and snowflakes and so on. So what snow crystals what type of snow crystals we can encounter in our snow cover? So it may look like here here are some example pictures from the microscope. So we can on the beginning there is pretty often snowflakes like that. So they are broken by the wind activity. Then, and if there is the isothermal metamorphism, we may find such grains, so pretty rounded, and in very cold conditions, they are often formed these faceted crystals or these depth hole crystals, so these pyramid shapes that are really dangerous in the mountains. But example, for the animals, these crystals are pretty nice because snow built from such crystals is pretty loose, and let's say mice or voles or some rodents may dig easily snow tunnels inside the snow cover and live inside the snow cover. And here we have also in the snow pit, we can encounter such ice layers, ice columns. Yeah, this is ice. This is much harder than the normal snow. So it's really problematic for some animals to dig in such snow pit because, for example, reindeers, they need a food in form of tundra. Right? So they need to dig in snow to get to the tundra and eat the tundra. And if they encountered such ice layer, it may be too hard to to break that layer and to get to the tundra, and they can die due to the hunger. Yeah? Not access to the food. They didn't have access to the food. So this is the very important also from the ecological reasons, yeah, for the living activity. And obviously there is a lot of other things that we can measure. Not always the snow pits are necessary. So for example, there are scientists that are interested in snow albedo because so albedo is this property that reflection, the amount of sunlight that are reflected from the snow. So it's different for the clean snow, for the fresh snow. It's different for the older and more polluted snow. And some scientists also collect the samples to measure in laboratory what chemical they can find in the Arctic snow. So there's a lot of things that we can measure in snow. And as I said, usually these snow measurements are in form of snow pits, and this snow cover examination in snow pit may take several hours. So my record is 12 hours spent in such snow pit. It was in the Arctic when we have 3 meters of snow. But I know from the colleagues that work in Polish Polar Station in Horsund that they may have even 7 meters of snow in some years, and I know that it was a record that they spent 3 days digging the snow pit. Yes, 7-meter deep snow pit, and with all the examination, all the studies that they performed inside this snow wall, it takes 3 days. And after such a huge amount of work, the result is in the form of such chart. So this is the most classical way of presenting the snow pit data. And this is informed in the diagram that include information about snow hardness. Here is the hardness, these bars. Density, we have here grain size, shape of every snow layer together with the temperature profile. So the really detailed chart about snow cover structure. And obviously, right now in the 21st century, there is some more. You don't need all the time to dig a snow pit to know about the snow cover structure, because we have some satellites that can help scientists to get some information from snow cover. So right now it's pretty easy to get the snow water equivalent from that is stored in the snowpack using the satellite sensors. And satellites are traveling around our globe from 50 years or something like that. So we have an information about snow cover extent, and we know that it's changing. So right now we have less and less snow than in previous years. So yeah, this is another proof of the climate warming. And it's really easy to get such pictures, and in the National Toolkit you will find some links where to look to find the information about snow cover in your area or in the world. And yeah, maybe go. So snow is a living environment, especially in the Arctic. If you have snow cover in the Arctic that persists on the ground for 9 months or 10 months or something like that, you know that animals and living organisms need to adapt to such conditions. And in snow cover there is quite a lot of life, in fact. So we have, for example, algae that are spotted only in the snow cover. So there's some specific species that lives only in the snowpack, and they in large concentrations they can make snow colored. So snow can be red, can be orange, can be green. There is no algae that makes snow yellow, so that's not a natural color of the snow. And so this is the living algae inside the snow cover. We also have plants that are really well adapted to the snow cover conditions. So, for example, this small plant from the Svalbard archipelago use the sunlight that is penetrating the snow cover, but they need only a small amount of sunlight to bloom. Yeah, so they even can bloom. They can even bloom under the snow cover. So it's really really nice adaptation. And we also have some spiders. We have some other insects live inside the snow cover, and we have some mice and voles and some small rodents that live inside the snow cover. And there are some predators that need to to live they need to eat. So they have some special hunting. They have some special they hunt in different way than normally. Yeah. So for the mice that live inside the snow cover, so it sometimes look like here on that picture. And there are also some birds that, let's say, can bury inside in snow cover, and they have a nest inside the snow cover. So, for example, here rock ptarmigans are birds that live in the Svalbard, and they stay for the whole year. Yeah, so they don't travel to the southern countries. They live in the Arctic for the whole year. And yeah, a few words more about this snow camouflage. Yes? So animals living in the Arctic need to adapt and be unseen for the predators or unseen for the prey. Yeah. So here we have the rock ptarmigan. It's the same bird, but during the summer it looks like that. It looks like here, and during the winter it's completely white. Only here it's a little small black eye, so it's really hard to see them on the snow. And in the summer, they are easier to see, but still they have these feeders in the color of the rocks, so it's also pretty hard to see them from the distance. And the same is for the predators. So during the Arctic foxes are completely white, but during the summer they are often the black. Yeah, so it's harder to see them on the snow surface or on the tundra surface ground. And as you can see here, the food chain in snow environment could be quite complicated, and it doesn't differ a lot from the normal food chains in different climatic zones. As you can see there, the food chain is pretty complicated. There is quite a lot of things that can live in snow cover. And we may divide such organisms that lives in the snow into three groups. So there is a subnival organisms that live below the snow, and there is some intranival organisms that live inside the snow cover, and they are mostly insects. And there are also some supranival organisms. So, for example, Arctic fox. Yeah, they are living above the snow, but they can eat some rodents that live below the snow cover, but they live above the snow, so they are supranival organisms. And on the end, I will tell you about few problems that face the Arctic due to the climate warming problem. So we probably know that right now we have, it's much warmer than let's say 100 years ago, and this is problematic also for the Arctic, for the snow cover conditions. So, for example, there is something called browning of tundra, and this is pretty weird. Maybe it may sound pretty weird. So if it's warmer, it should be better for the plants, yes, but not always. So there are some plant damages that are caused by frosts, because there is less snow cover. Yes, so snow cover have an insulation properties, and if we still have colds, but there is less snow cover, the plants can be damaged due to this, without this insulating protective layer of snow cover, they are affected by the frosts more than with the snow cover. There also is another problem for the plants. So if there is less snow cover, there is a reduction of the main freshwater source for Arctic plants. Yeah, so they are really adapted to the snow conditions, and they use the snow from the melting snow, the water from the melting snow. But if there is less snow, then they have some problems. And I told you about these ice layers inside the snow. So if such ice layers are created especially during rainfalls. So if we will have more frequent rain on snow events during winter, they will lead to formation of ice layers inside the snow cover or just below the snowpack, so directly on the ground. And such ice layers are really hard to penetrate for the herbivores, and they may, they have problems to access to the food. And obviously, if we will have smaller snow cover extent in the Arctic, our globe will warm even faster than right now, because there will be a higher solar absorption of solar radiation when the snow is absent. And obviously, there are some organisms that have strategies adapted to live in the snow. And if there will be problem with snow cover, then this organism will be replaced by some warmer by some organisms living in the warmer environment. So this is a treat for this cold these animals that live in the cold. And there is also such problems like more frequent algal blooms in snow at higher temperatures. And if we have algal blooms, and then that snow turns red or turn orange, for example, then it's reduce the albedo. So there is more solar radiation is absorbed by the snow, and that leads to faster melting of snow cover. So it's another factor that attract the global warming, so increase the global warming problem. And there is also something called the stabilization of permafrost. So snow cover protecting not only the plants but also the permafrost. And in the permafrost we can find, so this frozen ground, we can find some frozen microbes, viruses, bacteria that were in the past, but right now they are stored in the frozen ground, and they can be potentially dangerous. And it's happening right now because there were some studies that found that reindeers were polluted by some viruses that were stored in the Siberia in the permafrost, and when the permafrost is melted, and then these reindeers died due to this infection of that microbes that were stored in the permafrost. And there is a lot of more problems, but I think that's the most important things. And that was all. Thank you very much for your attention.
Watch other recordings from webinars on our YouTube channel, youtube.com/EDU-ARCTIC. EDU-ARCTIC 2. From polar research to scientific passion, innovative nature education in Poland and Norway receives a grant of 240,000 euros received from Iceland, Liechtenstein and Norway under EEA funds.